everyone. Welcome. My name is Wei. I'm a backend engineer at Box. Today we're going to talk about how at Box we use Solr to provide content search for businesses. So Box is an online cloud storage company, mainly for businesses. Our mission is to make organizations more productive, competitive, and collaborative by connecting people and with their most important information. This is how we are doing currently with our business. We have 225,000 businesses currently using Box, and our total user base is 25 million, and 99% of the Fortune 500 companies are current Box customers. Our Box search mission is in line with the Box mission, which is to make user content more reachable. And our goal is to replace the file folder browsing. So when you log into Box, your first thing to do is to use search to find your stuff. And this is how we're doing with our Box search. Our total index size is around 10 TB, which includes 10 billion documents. Our daily search, our daily requests volume is 100 million. Before I proceed, I would like to know how many of you ever used Box search before? Okay, about 30%. So I'm going to go briefly through what Box search is. So basically, we have two kinds of searches. One called quick search, and one is called full search. So quick search is there's a search box at the top of your account, and while you're typing, a drop-down starts to display. And this is what we call quick search. It searches the file name, basically. And if you pick any items from the drop-down, it goes directly to the file folders that you choose. But if you don't see any enough information here, you can click Enter. And then we will go to a UI called full search. So the full search has a little more information, such as match highlighting and a little more tools on the top. Basically allow you to fill out the result by the file size, modification time, or owner, etc. So full search also searches the file content, comparing to the quick search that only searches the file name. Any questions so far? So in the following presentation, I'm going to go through those things. We're going to talk about how we split the index, and how we make our search service highly available. And we're also going to talk about a few things we build on top of Solr to provide those business features users want. And we're also going to discuss what we are doing currently. And in the end, we will have time for questions. So as I mentioned earlier, our index is 10 TB. It's pretty huge. And it's probably larger than any single shard can handle. So we need to split the index into pieces. One natural way to do that is we can split the index by enterprise ID or by user ID, so all the enterprise's content go into one shard. But the problem of that is even a single enterprise's content might be too large for any shard. Not only that, when dealing with the search queries from larger enterprises, we probably want the query to be fanned out to more shards so that we can utilize more CPU powers or disk IOs. So in the end, we choose to use the file ID mod, the total number of shards, as the shard ID. So that basically split the things evenly across all shards for any users in enterprises. Which means in order to perform any query for user, we have to fan out the queries to all the shards and aggregate the result. So this is what essentially our current search system looks like. Now, the next question is, since user content is spreading across all the shards, how to narrow down the user scope so that users are only search their own stuff. This looks simple because we can use user ID to do the filtering. But remember, users are not only visible to have their own content, but can have share folders that is shared from other users. And those share folders, their owner are not the current user. So we have to do a little more things. So our search filter is the user ID plus the share folder ID list that you receive from other users. But that requires us to build several things into our index. The most important thing here is the parent folder ID list, which means for any file, we have to index all the parent folders, direct or indirect parent folders into the index. And if the file is moved between the folders, we have to reindex the entire content of the folder, which is a little painful, but this is how we're doing it. And of course, we also have the user IDs as part of the Solr document. So this is an example Solr index. So it has 4 files, which belongs to 2 users in this case, and they are on the different folders, as we can see here. So now imagine user 1 comes in and want to do a search. Assume user 1 is a new hire, it doesn't have any shared folders from other users. So the search scope of the user 1 is very simple. It basically is whatever file that is under the ownership of user 1. But imagine the second day someone share user 1 a folder called folder 2. It's not reflected here. But those sharings doesn't require any reindex of any files in index, so we don't see any changes here. But the search scope of the user 1 becomes what is at the bottom, so user 1 plus folder 2. And the real file that is going to search by user 1 has additional file called file 2 included. Now imagine on the third day, the user 2 who shared a file with user 1 choose to move that file out of folder 2 to a new folder called folder 5. As you can see here, the index gets updated. If you look at the folder 2 here, the parent folder becomes folder 5 rather than folder 2. So even though the user 1 search scope is remain the same, but the files is actually searched by user 1 gets changed. So it becomes 2 files. Any questions so far? Okay. So we can proceed to talk about how we do highly available search at Box. So by highly available, we really means 2 things. One is the index itself has to be complete and corruption-free at all time. And we also need to make the search queries be returned in a responsive manner, and make it include all the complete result. So it means 2 things. It requires us to have some redundancies in our system at the search, at the index level and at the search level. So at the index level, assuming we only have 1 copy of index, and if that copy goes wrong, our search is basically done. So we need to have more copies. One way to do it is we can have 1 master doing the index and being replicated, having the result being replicated to all the slaves, and have the slave serve the traffic. But the problem of that approach is the master can go wrong. Something feeding into the master is not complete or is corrupted, then all the errors going to be replicated to all the slaves. So which means we need a little more redundancy than that. So the way we choose to do is we choose to have multiple independent indexings that keep each index up to date. So here is how we are doing it. So assuming there's some updates from the front end, the updates could be the file upload, a new file upload, or any modifications to the existing files, like you change the file name or make comments of the file. All those events will end up becoming a index request in the index queue. And the index queue is immediately fan out to the number of sub-queues that you have. And each sub-queue is monitored by its own indexer. The indexers basically read popped items from the queue and read the rest of information from MySQL or file storage or whatever the source of the data is, and then make a Solr request to the Solr, and then it becomes part of the indexes of its own. So similarly, we also do have redundancies in the search workflow. I'm just going to show you how we do it. So assuming we have two data centers, and we have front end sitting in both of them, and the query is going to come into both of the data centers. So what the front end does is basically translate the user query into the query that Solr can understand and send to the head node. So instead of sending to the head node directly, it goes to a S3 proxy, which will choose the local head node in most cases. But in case if it's down, it will send the request to the remote head node in a remote data center. So the role of the head node is basically fan out the queries to all the shards and aggregates the shard response, and then send back the response to the front end. It does the fan out in a similar way. So it basically, for each shard, it goes through a S3 proxy, and the S3 proxy will choose a local shard and also remote shard if local one is not available. So in this way, we provide a shard level as well as a head node level kind of S3. Now let's talk about a few things we provide on top of Solr. So the first thing is file content search, meaning when during search, we are not just searching the file name, we are also searching the text inside of your files. We support most of the popular file types, such as PDF, PPT. So let's see how we do it. So during upload, the box front end gets the upload request, and basically it records the upload into information in MySQL, as well as putting the physical file into our file storage. It also sends a index request to the indexer, and which will start indexing immediately. At this time, only the file name becomes searchable, but the front end also tells a text extraction module saying, okay, extract the file content out of this file, which does it and store the result in another storage that we keep for extra file content. We keep it because we don't want to lose it. Later, if we want to do a full index, we can utilize those instead of extract the content again from the original file. And then once it's done, the text extraction module will tell the indexer again, okay, this file content is available, re-index again. And after that, the file content is searchable as well as the file name. As Box become a international company, we have customers storing documents in all kinds of languages. That requires us to support language-specific search. Oops. So how we do it is basically we have a language detector module in our indexer. When the raw file content comes in, it first goes through that module and detects what the language it is. And then we have a process in the indexer, basically copy the entire file content to a language-specific field, which has its own tokenization rule. And so basically it's tokenized in a language-specific way, and the result is stored in a language-specific field. At the search time, we basically search all the fields because search time language detection is kind of inaccurate and hard. Our current approach has some limitations. First of all, it's not scalable. We currently only support 8 languages, but if we want to support like 200 languages, we're going to have 200 more fields during search time to search. And every additional search field will cost you some kind of milliseconds during search time. So it's not really a scalable way. And I know there's some other ways to do it. Like in another session, I remember someone talk about putting a language tag in front of your original text, and then you can save your entire tokenization rule in a single field rather than spreading out to all different fields. But we haven't looked into it yet, and then it will require a lot of coding. And the other limitation is we only treat each document as a single language, which might not be the case because language can be of mixed documents can with mixed languages. So currently we only choose the dominant language and tokenize the document with that language. And we actually, so there's 2 parts. One is a file name and a file content. We actually, when detect language, we put all things together and then detect the language. And then we tokenize the file name and the file content in the same language. Sometimes it doesn't work very well because the file name might be an English name and the file content could be like a Japanese or Chinese. So yeah, so ideally we can do it separately, but this is how we are doing it. And we also providing search warm-up. This is mainly to increase the performance of search. So the theory is there's always a short window between the search box gets the keyboard focus, and then between that event and when the user starts to typing something into the search box. So this time can vary from 500 milliseconds or a couple of seconds. So the way we do it, when the search box gets the focus, we send a request immediately to the backend. And the backend does 2 things. One is to prepare the search filter. So what is a search filter? It is the username plus the parent folder ID list, as I mentioned earlier. And we put this information into a memcache. And we assume that information remains the same in the entire search session, which we define as 2 minutes. And if it's over 2 minutes, it just gets purged. And then we also send a warm-up query to a Solr, basically to warm up those internal caches in Solr, like a file cache or filter cache. Any questions so far?
What do you mean by keyboard focus? The jack?
Yeah, it's like you have an edit box in your search, in your UI, and whenever you click that search box, yeah, we will immediately send out a request. Now let's look at a couple things we are currently working on. So we are in a transition of merging quick search and full search. So we want the search result to be displayed immediately in the file folder listing area, and so that we can have the job done to display more suggestions, like the keywords that you searched before or the files that you selected before. And we also want to provide the advanced search functionality right in the search box. So you can type like file column, file type column, file type. So right in the search box, we want you to able to narrow down your search rather than only allow you to input the keyword. So something very similar to Gmail search. And we are also studying how to learn how to use machine learning to improve the search relevancy. So currently, all the rankings in our search is static, and we think we can do better. For example, if someone search a keyword and then pick a document to read it, and for like 5 minutes, we would assume this is a good result for the keyword. And next time you type the same keyword, we probably will move that document up a little so that you can find it easier. This is one of the examples. There's a lot of other things we can do, like if there's a hot document, like from your coworkers, when doing a certain keyword search, and you're most likely looking for the same document when you search the same keyword. So those things can be used to influence the ranking. And we are working on a internal module how to like track the search relevancy more accurately, like how to identify a click is a good click. Sometimes people are not able to find the things they want. They keep on clicking things. So a click is not necessarily the same as another click. We are working on how to like identify good clicks from bad clicks. And we are also working on logical sharding. As I mentioned earlier, we fan out the request to all the shards, which is very beneficial to us. But while we are growing, we have more shards, and then fan out becomes a bottleneck at some point. So we want to narrow down. We want to store the certain enterprises content in a subset of the shards, so that when the search time, you only search subset of the shards instead of the entire search cluster. And of course, while the enterprise is growing, we have to automatically increase the subset so that it will be their search response is not going degrading. Okay, that's it, and we are hiring. So if you're interested, shoot me an email. We are desperately looking for search engineers.
So one question about the extraction text from the document. Where is that extraction text also stored in Solr, or is it kept separate?
It's a separate storage that keeps the extract content of the file.
Well, why wouldn't you keep it in Solr? Because you use it for highlighting.
Oh yeah, we also keep the file content in the Solr for highlighting purpose, but at the same time, we also keep the content somewhere else. So maybe you want to do a reindex of the entire content, then you don't have to extract them again. So it's either in Solr as well as in a what we call a file storage. Yes?
What do you use for the extraction? Apache Tika, or do you have some sort of
We use Tika. Yeah.
Do you use Solr 4 or Solr 3?
Currently we use Solr 4.5.
But you don't use cloud?
Yeah, we don't use. Sorry.
I see a master slave model there.
Yeah, we don't use Solr Cloud mainly because we have multiple data centers, and within data center we don't have the luxury of have redundancies, so we don't. Yeah, so we only back up between the data centers, not within data center. But we don't want to create a Solr Cloud that across the data center, so we're still using just basic Solr. Yes.
Sorry, one more question. When you talk about warming up the data, how would you know how to warm up? Not how. What data to warm up?
You mean the request sent to Solr for Warmup?
Yes.
Yeah, this is an interesting topic. So we initially, so basically there's several things. When we want to warm up the filter cache, right? And we also want to warm up your document cache maybe as much as possible to have a good query hitting the Solr, but that is very hard. So currently we are doing like using the most common characters that starts a word as the warm-up query. We also experimented using like to aggregate whatever you search in the past and then find out the 10 most common keywords they use. But the problem is through the testing, we don't feel like there's a lot of improvements of that. So we are still using the hard-coded characters for warm-up purpose. Yes?
I meant to ask this before, but I thought you were going to talk about it. On that slide with the 4 files, I was wondering if the bottom right one, I guess, was a file in a subfolder. How is the subfolder structured? Is it a multi-value field?
Yes. The parent folder field is a multi-value field.
Okay, I don't have any parent.
Yeah, all the parent from the root folder will have a entry here, and the sequence doesn't matter. Yes?
What's your query volume in that first slide?
Oh no, that is actually what we call request volume. So majority of it is the index volume, but we do have a certain amount of search volume. I think at the peak we are looking at like a 100 QPS. Yeah, that's what I know. Yes.
Do you have a custom similarity module, or how do you deal with the inverse document frequency of all the users together? Term frequency.
You mean the term frequencies we use are going to mix between the users? Yes, that's currently we are doing, which is not ideal, but
Okay,
yeah.
so you just let it the way it is.
Yeah.
And how many users do you have?
25 million. It's probably a couple months old, so I don't know the current data. Sorry. Yes. That is out of box of Solr, so there's no like normalizations between the term frequencies between different shards, so it's just work as it is. Yeah, yeah. All right, okay.
Do you index user permissions or acronyms, or is it all based on folders?
So the current way we do the access control is mainly through the visibility, which is building into our filter, basically user ID plus the parent folder ID list. But we do have like a business logic that is gonna be applied on the result that returned to be returned by Solr, and then we're gonna do the filtering again. But in most cases, the result will be the same because the filtering is already being applied at the query time, but the index might be a little delayed, so we still apply another kind of visibility check on top of the result that returned by Solr.
So post-filtering results?
Yeah. All right. Thank you.